Welcome Room 17 students. Today we are going to be learning Module 4, Lesson 10. I'm going to be reviewing the concept development portion of this lesson. Our learning objective today is I can compare and evaluate expressions with parentheses. All right, let's take a look at problem number 1. It says, write an expression to match a tape diagram, then evaluate. So let's read the expression that names the whole. 9 plus 11. So our whole is the sum of 9 and 11. How many units is the sum being divided into? 1, 2, 3, 4. That's fourths. How many fourths are we trying to find? 3/4. So this tape diagram is showing 3/4 of the sum of 9 and 11. We can write that in a few different ways. The first way we can write that is the sum of 9 plus 11. And we're trying to figure out what 3/4 of that sum is. Another way we can write it is use commutative property and figure out what is 3/4 of the sum, or let's actually turn that into a multiplication sign, and then use our parentheses to represent 9 plus 11 as the sum. Now, we're going to want to make sure that we use parentheses to find this out first, because if we don't, what we're going to do is we're going to end up doing 3/4 times 9 and then adding the 11 to that. That's going to give us a totally different answer. So we're going to make sure that we separate the 9 plus 11 as the sum. And another way we can also write it is we can write 9 plus 11, which is our total. And we could divide that by 4. If we take our total, 9 plus 11, and divide it by 4, it's going to give us the amount per unit. It's going to give us these. And since we're looking for what 3 out of the 4 is, we would then have to do times 3. Now that I've shown you 3 different ways that you could write this expression to match the tape diagram, let's do the final portion of the problem and evaluate. So let me go ahead and get rid of just the bottom 2. Let's stick with the first one. So let's first do the parentheses, like always, 9 plus 11, which equals 20, and times that by 3/4. I'm going to look for cross-canceling opportunities. I know that I can divide both 20 and 4 by 4, and I can get 5 and 1. So my new equation would be 5 times 3 over 1, which equals 15. Oops, sorry. 15 over 1, which gives me 15. That means that 3/4 of the sum, 9 plus 11, equals 15. That would also further let me know that each one of these units is 5, although that's not what they're asking for. All right, let's look at this example of the tape diagram. How is this different from the previous example? This time we do not know the total or the whole amount. We know that this diagram is being divided into 1, 2, 3, 4, 5 equal parts, fifths instead of fourths. What we do know is that one of these units here is equal to the difference. Remember, subtraction is the difference. In the last example, we looked for the sum when we added, but in this example, we're going to find the difference, and that difference is going to tell us what our single unit is. So what are some ways we could write this expression? Well, one way we could write this expression is we could say 1/3 minus 1/4, or the difference between 1/3 and 1/4 times 5. That would be one way to write the expression. Another way, due to commutative property, would be to put the 5 in front and say 5 times the difference of 1/3 minus 1/4. Let's go ahead and evaluate or solve for the answer. Now, in order to subtract 1/3 minus 1/4, we're going to have to figure out a common denominator, a common unit, which is 12. 3 goes into 12 4 times. 4 times 1 is 4. We're going to subtract 4 twelfths. 4 goes into 12 3 times. What we do to the bottom, we do to the top, minus 3 twelfths, which equals 1/12. That means each of these single units up here is equal to 1/12. And remember, we're trying to figure out what the total is. So let's not forget to take our answer to this section right here, 1/3 minus 1/4, and now we have to times that by 12. I'm going to look for cross-canceling opportunities. There are none. My answer is 5/12. You'll also probably be able to notice that it's 5/12 because if you add 1/12 plus 1/12 plus 1/12 5 times, you'll get 5/12. All right. The next problem 2 says to write and evaluate an expression from word form. And that expression is right here. Let me pull it up. Hold on. The product of 4 and 2 divided by 3. So think about how you would write that using an expression. So when you look at the word, the sentence, the expression in word form, you'll notice some things that will give you some clues. So for example, product. I know that product is the answer to a multiplication problem. And it says the product of 4 and 2. So that means 4 and 2 is going to give me a product. And that product is then going to be divided by 3. So I need to first figure out the product of 4 and 2 and then divide that by 3. So there's one way of writing that expression numerically. Another way we could write that expression is 4 times 2, the product of 4 and 2, divided by 3. Because remember, a fraction sign is also a division sign. And one last way you could write this would also be to just drop the multiplication sign, the parentheses, and to write 4 times 2 divided by 3. Because when you solve this problem right here, let's go ahead and do it. 4 times 2 is 8. And then take that 8 and divide it by 3. That's going to give you 2 2/3. Okay? Now, when you do this, remember when you have two different signs, the multiplication and the division sign are what we called in class twins. It doesn't matter when you're solving. One is not first and the other is not first. It's just whatever one pops up first when you're solving from left to right. So when I'm solving this from left to right, the multiplication sign happens first. So see, it happens first. So I actually don't need these parentheses because it happens first. So 4 times 2 is 8 divided by 3. Well, that gives us the same answer, 2 2/3. Problem 3 wants us to evaluate and compare equivalent expressions. So it gives us some different ways that we see these expressions are written, and we're going to evaluate them so that we can compare them. So let's go ahead and look at A. 2 divided by 3 times 4. Well, if I go like that, I'm going to get 4 times 2 is 8/3. And that's going to equal 3, 6, remainder of 2, denominator of 3. Okay, let's look at B. 4/3 doubled. So if I have 4/3 2 times, I can do times 2. I would get 8/3 again. Hey, there was 8/3 right here. 2 2/3. We have a matching expression. We can write it like this, or it can be written like this to equal the same. Let's go to C. Now C looks a lot like A. If you can see, we see the 2, the division sign, the division sign. These parentheses are new to C. A doesn't have those parentheses. Let's go ahead and solve C and see if we get a different answer. Okay, let's go with that one. Okay, so first we're going to do the parentheses. So 3 times 4 is 12. We're going to now do 2 divided by 12, which also can be reduced or simplified to 1/6. Wow, when we added those parentheses, we did get a different answer. Those parentheses really do matter. Let's go ahead to D. 2/3, 4 times, well, let's just do times 4, carry it across. That's 8/3 again, which is 2 2/3. And then E says 4 copies of the sum of 1/3. This should say and 1/3. I didn't write that all the way down. So the sum of 1/3 and 1/3 is 2/3. I know that. And 2/3, they said 4 copies of that. That gives me 4 times 2 is 8/3. Oh, another 2 2/3. And then finally, let's go ahead and look at 2 divided by 3. Remember, we're going to use these parentheses. So 2 divided by 3, I can write it like that, times 4. Put that across. I've got 8/3 again. So you can see in all these ways, F, E, D, B, and A, those are all the same ways of expressing 2 2/3 or 8/3. C, we had a little bit of a problem because somebody added some parentheses there and it changed. All right, problem 4 is going to have us compare expressions in word and numerical forms, and then we're going to, in the circle, write which one's bigger using the open alligator mouth or an equal sign. So let's go ahead and look at A. It says 1/8 the sum of 6 and 14. Well, let me just start by figuring out, well, what is the sum of 6 and 14? Well, that's 20. I know that. And now I'm going to figure out 1/8 of 20. So is there possibilities for cross-canceling, or maybe I'll just go like that? Oh my goodness sakes. And then 8 goes into 20, 8, 16. There's 4 left over, 4 8s, which also is equal to 1/2. I don't know what is going on there. Okay, so now let's look at this one. 6 was 14, that's 20. And then let's divide that by 8. Wait, isn't that what I did over here? 20 divided by 8. Yep, that's going to be equal. Okay, let's look at the next one. We have 4 times 8/3. Well, that's easy enough to do because we've been doing these. That's 8, 16, 24, 32 over 3, which gives us 10 2/3. And we're going to do that versus 4 times the quotient of 3 and 8. Okay, well, I see one of those words. It says 4 times the quotient of 3 and 8. That lets me know that the quotient is a division answer of 3 and 8. So that is 4 times the quotient of 3 divided by 8. Well, what I'm noticing here is this looks a lot like this other one I did here, because right here I did 4 times 8/3, and over here I'm doing 4 times 3/8. So without even finding the answer and trying to figure out which one's bigger, I already know this one's going to be bigger. And I know it because 4 times 3/8, this is less than 1 whole, 3/8. But this one right here times 8/3, well, that's more than 1 whole, because 8, that's an improper fraction. So I don't even actually need to figure it out to know that this one is the larger one. Okay, let's look at C. It says subtract 2 from 1/2 of 9. Well, 1/2 of 9 means 9 cut in half. And if I was to do that, 2, 4, 6, 8, it's not even, but I can still figure it out. It's 4 and 1/2. That's half of 9. Now I'm going to subtract 2 from that. So I have 4 holes right here. I'm going to subtract 2 holes. That's going to give me 2 holes left with that 1/2 still. Now let's compare that to this other side. It says 11 divided by 2. Okay, 11 divided by 2. 2 goes into 11. Let's see. 5 times with 1/2 left over. And now I'm going to subtract the 2 right here. And when I do that, I know that I'm still going to have 3 holes left over with the 1/2. So what I'm comparing here is 2.5 to 3.5. I know that 3.5 is going to win. All right, that is it for today's concept development problems. Go ahead and do your homework now. On Thursday, we're going to check in at our usual time, 2 o'clock. If any of the homework problems are stressing you out or you find difficult, try the homework help that I've attached. And if that's not working, please check in with your questions already ready to go at 2 o'clock on Thursday. I'm happy to help you. I look forward to seeing you guys. Good job. Keep up the good work. And we'll see each other soon. Take care.